Your biggest judges.
Okay, so today we're going to start with a question, which is, why do we travel south from Montreal in winter? Victoria.
It's warm.
It's warm. Okay. It's warm compared to
Where we are in Montreal.
where we are. So compared to, I could say Montreal.
Yes, just where we are in Montreal.
Okay. So we're going to look at, this is a typical weather map of North America from January. I want you to completely ignore the colors. We're not going to be paying attention to the colors that are here. What I want you to focus on are the numbers. Okay? So right off the bat, what do you notice about the numbers across North America?
Or Alaska.
Jen?
They're all negative.
They're negative. Where?
Oh.
Where are they negative?
We're in the north.
In the north. Okay, so we have more negative numbers in the north. More negative north. And what else do we notice then? If there are more negative in the north, what else are we noticing? Jen again.
More positive in the south.
More
It's
positive in the
hotter
south.
in the south.
And that means that it would be hotter, right?
Yeah.
More positive in the south, which this means hotter. Okay, so we've established with this weather map that this is from January. The north is colder because it's more negative numbers, and the south is warmer because it's more positive numbers. Which before, when we said why do we tend to travel south from Montreal in winter, we're going towards warmer, right? Okay, so the next question then would be, why is it warmer in the south when it is colder in Montreal? So we're going to look at some of your initial ideas. Ooh, we're going to look at some of your initial ideas. There are no wrong ideas. There's wrong spelling. But there's no wrong ideas. Okay? So just shoot off the top of your head, why do you think it's warmer in the south when it's colder in Montreal? Victoria.
The equator.
Okay, the equator. What about the equator?
That was mine.
Okay, so we had two for the equator. Eric and Victoria mentioned the equator, but what about the equator?
It's warmer at the equator.
It's warmer at the equator. Okay. Warmer at the equator. Okay, anyone else? Anything else?
The water's warmer
The water's warmer where?
near the equator.
The water's warmer near the equator. So, if I get what you're saying, the warmer water is making it warmer all over near the equator.
Of course.
So warmer water equals warmer. Okay. Or maybe we can say warmer water equals warmer land. Is that fair?
Sure.
Okay. Jen.
I feel like the sun shines on the equator more than anywhere else in the world.
The sun shines on the equator more than anywhere else in the world. Okay, so you think there's more sunlight on the equator? Is that fair? Is that what you
Or
said?
it's closer to the sun, the way it's axis, you know.
It's tilted, right? You're doing with your hands the tilt, which is something that we covered when we looked at the Earth. So you're saying that, what are you saying?
I think it's hotter at the equator because I find it's more like sunnier.
It's hotter at the
Has
equator
better
because it's more
access to the sun.
sunnier. Okay, so I'm gonna write that down. Hotter at equator, hotter at equator, because there's more sun.
Because of the sun.
More sun. But you also said something about you did this for the tilt.
Yeah.
What were you getting at
I
then?
feel like the sun's always on the, well, it's not always, but when it rotates, it's not. But I feel like the sun doesn't reach like the top and the bottom. But it reaches
So the sun doesn't reach the top and the bottom in the same way it reaches the equator?
Yeah.
Okay. Sun reaches equator differently at top versus equator. Is that fair? Yeah? Sophie, you got your hand up?
I was gonna say it's harder at the equator because there's more sun, because I think it's more concentrated.
Okay, so more sun, more concentrated. Is that okay if I add that to Jen's point?
Absolutely.
Okay, more concentrated. Okay? Any other ideas? Victoria?
Aren't the seasons reversed between the northern and southern hemisphere?
Seasons are reversed between the northern and seasons are reversed between the northern and southern hemisphere. Okay?
So then it'd be hotter in the southern hemisphere. Because in January, which is winter in the north, would be summer in the south.
Okay, so can we say then that the seasons are reversed?
Yes, ma'am.
Okay? Seasons reversed between north and south. Why? Why do you think that? Why do we think that? Why do we think the seasons are reversed between the north and the south? Do we think Victoria's idea could have anything to do with any of the other ideas on here? Do you see any links here between the ideas? Maybe? Victoria?
They all have to do with the equator?
They maybe all have to do with the equator. Okay, so maybe we can say that these two are tied together.
They all have to do with the warmth and the sun.
They all have to do with the warmth of the sun. Okay. Okay. Do we think when we looked back, think back to when we learned about energy. We learned about solar energy. Do you remember? You do. That we talked about how the energy coming from the sun as a source is constant. Right? So the sun is a constant source of same energy. So then can we then say that there's more sun in one place or another?
No, but it's more concentrated.
So we're going to stick with more concentrated. Does everyone agree with more concentrated?
Mm-hmm.
More concentrated. Okay, so we're really going to stick to more concentrated. And when we're saying more sun, that's what we mean.
Yeah.
Okay? Okay, good. So we're going to look a little more at some of these ideas. And you're going to work on in teams to do a model. But what I wanted to show you first is a little demo, which now I will need to hit the link actually.
Oh, nice. Oh, nice.
So
Nice dance.
fancy.
Moonlight here. Yeah. Like how it's not too abrupt, you know? Nice soft. Soft.
You know, music.
So we don't go snoozing.
Okay, so I don't have a proper flashlight, but
I have on my phone.
me too, that's what I'm gonna use, but thank you. Okay, so you remember that when we talked about the Earth, its properties, we talked about how it rotates, we talked about how it revolves, and it's revolving while it's rotating. Okay, we talked about how it's revolving around the sun, which is our source of light and energy, okay? And we specifically talked about how it's tilted. It's tilted around this center axis. Okay, this we already discussed. So now we need to think about how the sun, which is going to be the phone, is hitting the Earth. Okay, and what do you notice about the light? Okay, so before I show you on a globe, what I want to show you, but didn't bring, so I'll make up. If I shine the light directly on this piece of paper, what can we say about the light on that piece of paper?
It's bright.
It's bright. Excellent, it's bright. Going back to the idea, Sophie.
I was gonna say that there's like a really bright circle and then there's like a lighter circle.
There's a lighter circle around it. Okay, what can we say about that really bright circle other than it's bright?
It's concentrated.
It's concentrated, right? Which goes back to the idea that we had about more sun being more concentrated. What can you say now if I tilt this piece of paper?
It's bigger.
It's more
It gets
spread
bigger, it's more spread out, right? Is it more or less concentrated?
out.
Less concentrated. Okay, so let's have that same thinking with the globe, okay? So right now, we have the globe being tilted away from our source of light. I'm gonna shine it straight on. So So you need to think about, and you don't have to answer this because you're gonna model what you're seeing. So I want you to think about how the light is hitting the equator and how the light is hitting, for example, North America and Montreal up here. And think about the places near the equator, think about places you go on vacation, Florida, Mexico, and where they are, okay? When you do your model, I'm gonna want you to identify Montreal and some southern destination of your choosing. But right now, you have to think about how the Earth is tilted. If I were to tilt it towards the sun, you then need to think about, Montreal's here, once again, how is the light hitting the equator? Okay, we talked about the equator a lot. And how is it hitting Montreal? Something else that was brought up by Victoria was how the seasons are reversed. So you can think about that as well. Montreal is up here, Australia is over here, and you need to think about how the light might be hitting there as well, keeping in mind that the Earth is rotating all the time. Okay? So you can work in groups of 2 and one group of 3, and you're going to create a model using this big paper. Okay? Modeling, if you remember, we did it already in one of your labs, and you did it when we did cycles of the day and night. Okay, so modeling, you have to always label. I started the model for you, so I've drawn the sun here, okay? I chose to draw it here. You then have to draw the Earth and draw what you think is happening with the seasons. Think about how the light is hitting the Earth. Think about the path of the Earth. What's the Earth doing all the time? And you want to also draw me 2 or 3 locations, strategic locations. Okay? And I also want you to identify what season do you think you're drawing when you draw it. You guys are very familiar with the 4 seasons, having learned them in elementary school, so you need to think about that as well. Okay? So, I'm just going to put the lights back on actually.
Want to be a partner?
Will you be my partner?
You're now having a short intermission. What, readjust the difficulty.
Make sure it's filming on the working.
Hence, short intermission because I just knocked the phone over. Somehow it sounds different when you ask someone to be your partner in university than in high school.
What it looks like. Hair up, it's like back dash.
Okay, sticky on this one side. You can stick it on the desk. Now 2 markers.
Oh, you guys are really wow.
Ours low.
Okay.
Well, that tells you something about how bad the stuff is in high school.
And I'm going to come around and redo the demo individually for your groups, and we'll do another look at it and think about it.
Okay, or do what?
We're allowed to go.
You know, all we're ever going to see, anyone's going to see is my large bag, right?
I don't want to move this up. I'm sure.
So seasons, let's think about seasons. Not
This is
seasons,
the
that
sun.
is why is
Seasons
it,
So
in
where
the
would
sun?
we put the earth? Right?
why is it summer
God.
and winter, the hemispheres opposite?
Because
That's stuff.
it's summer when you get more sun, and it's winter when you get less sun.
But the sun's when
No, because the sun is always a constant, it's always the same.
Yes.
No, the sun is
Where do we
constant,
put the
but
earth?
where it hits on the
Where do
earth.
you think the Earth should
Yeah.
go?
I think inconsistent.
Okay.
Now, where's the equator on this?
That's
Is
what you
it
think?
straight like this?
Well,
Is
the
it
sun
like
doesn't have an
this?
equator.
Right?
No, no, this
Remember about when we
Oh,
talked
that's
about
the
how
sun,
the
sorry.
Earth is
I thought that
revolving
was
around the sun?
going on
So the
to
sun is
earth.
on one side of this,
Oh,
right?
the
And we also
sun's
talked how
here.
it follows a circular orbit,
Are we just
but you don't have the whole circle,
Hold on.
right?
Is
So
this
you
the
don't
sun?
draw- That is the sun.
You know what we're gonna do?
We
We're
failed.
gonna draw a circle and then we'll put the
Or
axis
should
where
I
we
say-
want so we can see where it's tilted.
I think I failed this one. It's
I'm gonna go around and show models of it.
Oh, yeah, nice circle. You didn't even need the thing.
Okay, so that's
The
the sun.
compass,
Okay.
yeah.
So what did you say?
So,
We should draw on sushi.
all right,
I
So
think
we
what we decided was
looked at how
it gets and nothing.
this would be the sun and how it's hitting the Earth, right? So in your model, you have the sun and you have the Earth, right? And you want to think about which way it's tilted here. You can draw it the tilt whichever way you like. Okay, you might want to indicate the tilt. Make sure you label your picture, your model, and then you want to think about how the sun's rays are hitting the Earth and where they're hitting the Earth. Okay? And then you can also think about how it would revolve around and how at times it's going to be tilted toward the sun.
No.
And what
You
impacts the
see
light
me
would
do
have.
it.
That's where I get confused, because you want more than
Susan's a
one.
very good artist.
That's like, are we just
You
doing
can
a
focus
one-
on one depiction, just make sure that you, the reason I show both
Maybe you draw
is
better
because there are the
things
four
that
seasons,
don't
and
work.
you need to indicate which one you're drawing.
Oh my god, I love you so badly.
You want to tell them.
Okay, so,
Okay, we're gonna teach. So far, we got teach nowhere.
alright, so in the demo that we did,
Alright, sun, yeah,
this is, the light is representing the sun,
yeah, so it's
Okay.
like the.
and
this is
we then
the
have
northern, this is southern,
the
or
earth.
like that. Okay.
and in this case, the earth is tilted away from the sun.
Like this? What do you mean by away from the sun?
So the tilt, we talked about how the earth has an
Oh,
axis,
right, it would
so
be,
it's
okay,
tilted this
got it.
way.
Yeah.
And the sun is hitting directly. Now the sun, as we covered, never moves. It's always in the same place.
Yeah,
The
yeah.
earth is moving,
Yeah, yeah.
revolving around the sun and rotating.
Yeah.
So you want to think about, thank you, you want to think about how, where the sun is hitting and what effect that might be having on the difference we talked about between it being warmer down south and colder up north.
How do you remember it? You
And we
just
talked
remember
about what effects the sun might be having
Okay.
and how the tilt might affect it, right? We also talked about what happens when it's over here and the sun is on this side.
Yeah, what's up?
Now it's tilted towards the sun.
All those braids.
You don't have to draw both that I just showed. You
Okay,
can
so
draw
where's
one
the
of the
sun getting?
seasons, but you need to indicate which one you're drawing.
Okay, so where's?
Okay, so we need to draw the earth, that's right. Just make a big old circle, yes, gang?
Yeah,
Yes, a circle.
it's smaller,
Definitely a
smaller than the
circle.
sun.
Yeah, it's not flat here.
What? Everything I learned in
Just
school is
not flat
wrong,
today.
but the earth is not flat. We need to draw an equator. Don't draw the equator just yet. We also have to draw the tilt. Wait.
No, 'cause it's- Do we have to make it tilt away, you said?
It depends on where it is in the cycle.
It depends.
Oh, it depends, it's up to us.
Yeah, so you can draw the tilt however you'd like.
Because at certain points of the year,
Okay,
the bottom
so-
of the earth is tilted towards the sun, which is
How
when
we
there's
doing?
more sun, like it's warmer,
How we doing?
when some are there, when it's here.
Okay.
And then other points.
So where are
do
you
we get the-
indicating your
would
tilt?
we draw the equator first to show
I'm gonna
where
draw the
it's
equator
tilted?
this
So
way.
do you remember how we talked about
Got the equator that way?
through the center of the earth?
Yes, you say
There's
so?
an axis.
Well, that's actually, sorry, that's the axis, not the equator.
But it's not.
Okay,
to
but
draw
is this
across?
drawn straight up and down or is it
No.
tilted?
That would be a little like this.
No, the
Alright, but you might want
axis
to
is here.
indicate that tilt a little stronger.
Oh, gotcha, okay, so.
Okay, 'cause think about-
Tilt.
Think about when
Okay,
we
let's do
tilted the paper
And
Oh,
then-
yeah, I got it.
or the earth was tilted.
And then the equator.
If you think about it, I had the flashlight here and I had the paper
Supposed
straight
to look
up.
like this?
I had to really tilt the paper to get that effect.
That's her
So
part.
you need to think about that.
Yeah, you kind of knew that, but.
The sun-
Well,
Where do you have a new model?
Equator?
And then you write like summer here. and winter
Oh, she has extras!
She must have known.
here. Wow, she knows as well.
Where you get that paper?
Okay,
I don't know,
She gets it
students.
from the paper fairy.
okay, I'm gonna do it like
Alright, I'll do it.
right next. Okay, I can put a little,
Okay, so the sun is,
this way or this way, what do you want?
if it's shining
Whatever.
there.
We're not talking this.
Yeah, I know.
It doesn't have to be exact.
Okay, we're gonna
When
tilt
you're
it.
modeling,
Very nice.
You know what,
they
they
have to be
tilted it
straight
that way,
lines.
so we're gonna tilt it this way.
Hey,
What?
what are you looking back here? I saw you sneak.
Reverse copycat?
Miss,
then we got
miss,
our,
I'm
Jenny
looking
Chen is
at my
going to be very
work,
upset
miss.
with you.
Shredded wheat.
Alright, what do we have back here?
Equator.
We're sort of
Okay.
playing around.
We're gonna say.
Okay,
MTL
So you have the
is,
axis, you have the equator,
Spread out.
what,
Now we pick
winter,
the season, right?
summer.
Concentrated.
You've got to pick
Oh, that's really smart.
what summer you have. So you have the
Okay.
seasons. Okay, you might want to now indicate
Alright, so now the
different
sun's coming
places.
in,
Yeah,
right on us.
Okay.
You mean blue?
So do
we could do like
Okay.
Montreal.
North America,
Okay,
Australia.
Alright, so should I do like a little funnel?
I don't know how to draw.
and then
Not right.
We just write it, but honestly, I'm not
Try to get-
also you need to think about how the light is going to be hitting
So we
here
keep
Yeah.
doing that.
and here
Yeah.
and here.
Yeah.
So you've tilted away from
Okay.
the sun here, right?
So
We
this
agree
would
that
be
you've tilted away in your
closer to
picture.
Mhm.
Okay, so
And it's like dark over here.
would the light be going straight on here? Because your picture's
Like
really
arrow,
Okay.
right here or right next to it.
Hey, I'm not artiste.
I live in teacher.
Think about
Lousy teeth.
what I want you to think about here is just think about the concept because you've focused on two sides of the earth.
Yeah.
Try and focus on one side of the earth and think about the difference of the light hitting here and the difference of the light hitting up here.
Oh, okay, so.
So think about
I
that.
thought this was straight, but it's.
Okay?
Don't.
I did draw you.
Oh my god.
Okay, don't draw on each other.
I did draw her. Just give her time out.
This line is actually supposed to be a bit straighter.
Okay,
So
so,
this right either.
That's not a penis, it's an arrow.
now we have, okay, but what I want you
I
to
thought it
think
was
about
penis
here
class,
in your
I'm
drawing is
That's
Okay,
concentrated.
that's a penis.
when we
And
covered
You can give it a refresher course.
On the side.
when we covered the tilt of the earth,
So
we
where's
talked
it
about how
focused in
the
the sun?
axis
Right?
goes through the northern hemisphere
Yeah,
and
so
the
the
southern
strongest
God,
one
it's
would
right
be
at the equator.
So just think about
So what's near the
what you've
equator?
drawn
What are
here,
some vacation places near the
right?
equator
And
that
does
we
that
haven't
show
Okay.
where the axis would cut
Really?
through?
I don't know.
I don't know.
Did it?
I think-
Just
what's
change
near
South
the equator?
America.
So you have your, oh, sorry, I thought this was your axis. What is your axis, this?
Yeah.
Further.
Ah, okay. So what are you, what
cities?
season are we drawing here?
Summer.
Label
What
that.
North
Okay,
America?
and you need
What's
to
close
talk
to
about
the
why.
Vacation.
Near the equator. Venezuela, Colombia, Ecuador.
Okay, you need to label what this is, label what this is.
Where I
Which
should
excuse me.
summer
What
Why?
this
So you do
is.
the other monkeys?
with all the animals.
Alright, well,
Kenya.
now we're
Alright.
trying to
Okay, let's look
we got our
at
compass.
People actually very rarely
yeah, I
go
guess-
to.
Right, but what is this line? There you go.
Panama, I see what you want.
Okay.
I know what you want.
People.
Finish your models. Sure. Right? And what we're going to do is I'm going to have you come, put it up here, and you can explain, you're going to need to explain your model, explain specifically how your model is showing this temperature difference that we talked about. Okay? And how the sun is affecting the temperature difference. Okay? So Jenny Victoria, why don't you come up? One you can stick it, and the other one and then hold. One just over there? Yes. Yeah.
The other way, so it'll actually stick.
That's a good call. Okay.
Right?
So, and then while you're
So they're supposed to
explaining
teach
it,
you
we're
for the
gonna
class.
work out some of the ideas. Okay? So, explain to me what is happening in your model. Yeah.
The earth.
That's the earth, okay?
We got our axis.
Okay, excellent. So which way is yours tilted?
That
In relation to the sun?
Towards.
Towards. Okay, so we talked about, in the past, remember we talked about what it means when something relates to something else. Okay, so here we're talking about how the earth is positioned relative to the sun. Okay, so we have it tilted towards. Excellent.
got the equator.
Okay. Yeah.
Summer up top.
Okay.
Winter down low.
Okay, now why is it summer up top?
Because the sun's looking at it.
The sun's looking at it, okay? And can we say anything about, we talked a lot about here, hotter at the equator, more sun, more concentrated.
So, yeah. We put Montreal there.
Mhm.
And I guess actually it would be like going all the way to the equator, concentrated. But we figured Montreal was on its path, so.
Okay, and then what can we say about down here?
Cold, or,
Okay, what about the concentration of the sun?
uh,
Less. So here we're saying, again, summer is when it's tilted towards. Okay, tilt towards sun. And what are we saying about the sun?
It's concentrated.
It's concentrated, so more concentrated. Is that about it? Does anyone disagree with anything in their model? Does anything not make sense?
Is Montreal south of the equator?
No, north. North.
Oh, okay.
Okay? Anything else that we don't
I
understand or
apologize.
isn't quite clear in their model?
Why is this sun so smarmy?
Looks good? Okay, so why don't we get now
Are we supposed to disagree?
Sophie and Carol
Do you want me to disagree? I can
are going to come up.
We are?
Thank you, ladies.
Thank you,
They're
ladies.
come up and show their model.
Often you get a chance to that.
Let's rock this, Sophie. Yeah! Be in front of the witness again. All right. Feel very exposed.
It's okay, I filmed it.
Okay. So, who's going to hold, who's going to explain?
It's a bright sun.
You're going to explain.
No, I'm going to explain.
Okay.
Brett
You're
students
gonna
too.
hold and one of your- all right, Sophie, go on. All right, let's listen to
Sushi can't hold.
what, yeah.
Here is our axis, and it's tilted
anyone have any questions about their model?
Jerry, no, I like it. I think it makes a lot of sense. I like the rays.
Okay.
I think the
So
Earth is too
now
close to the sun.
What we can try and do. No, I don't think it's going to be effective.
You draw next time.
I did.
Back to back. Okay, that'll work. Charles, you can stay up here. Okay. All right, you guys.
That's
can,
a very
Carol,
creative
feel
solution,
free to
Carol.
Sit down, ladies. I'm going to take your model.
Ah, that's perfect.
Yes, you can probably hold both of them at the same point. Yeah, she drew these wrong.
You just need
So
more
we're
saliva.
covering them a little bit.
Do anything right.
What do we notice is similar between Carol and Sophie's model and Jen and Victoria's model? Eric, you
The sun.
Okay, the sun is similar, the position of the sun. And when we talked about the sun, we talked about how the sun's always in the same position. So that would be similar, right? Because it doesn't move. Sophie.
No, sorry, I was gonna say, they're like in the same, they're in
Yeah,
the same place, both of
totally
them are in
thinking
the
the
same
same.
place.
Okay, so both of them are in the same place. What are we talking about in the same place? The Earth?
The Earth is
The
circular.
Earth is rotate, is not in this, okay, take it back, I take
Take
it
it
back.
back. Okay,
I'm
take it
done.
back.
Change my mind.
Something I want to point out is, again, talking about relative to one another, right? One of these is depicting winter and one of them is depicting summer. What can we say about the distance between the sun and the earth?
It's really little.
Stays the same.
Yeah, it stays the same.
It stays the same, right? So
The equator's totally different on both.
what we are looking at is that what is very different in these two models?
The tilt.
The tilt is very different in these two models.
Areas, yeah. Like
And the
what's
tilt-
being affected.
Affects what of the sunlight?
Concentration.
Concentration, which then affects
Bingo.
whether it's warmer or colder, right?
The season.
Which is the seasons, exactly.
Woo!
Bravo.
Okay, so we can take these down. Yes, we can.
Very good.
Do it all at once.
We owe it all to our teachers.
Okay, and so
She's swell.
then we'll look at next class. We're going to continue to look at the seasons. We're going to look at the solstices, the equinox. Okay? We didn't talk about equinox. We didn't talk about fall or spring. If you remember from seasons which you learned, fall and spring fall between winter and summer. So now we got to figure out what happens in between here. Right? If we're thinking of fall and spring.
Oh,
But today, we focus on winter and summer, and we've determined how the tilt is really impacting how the light is hitting the earth, and is impacting the big seasonal differences.